This video covers correlation and regression. We're going to talk about scatter plots and regression equations. First, let's talk about a new word, correlation. A correlation exists between two variables when the values of one variable are somehow associated with the values of the other variable. So correlation means the two variables are associated. Sometimes we interchange the word correlation and associated. You'll see both. Then we have regression. Regression is an equation that describes the relationship between the two variables. So it shows the relationship in the two variables that are correlated. So let's look at this example. This is a table that represents a set of ordered pairs. Each ordered pair represents a house. The independent variable, or the x, is the square footage of the house, how big it is. And the y-coordinate, or the dependent variable, is the selling price in thousands of dollars. Now, if we were to plot these on a graph, it would form what is called a scatter plot. So a scatter plot is where we gather data that has two parts, an x and a y, and then we plot those numerical points onto a coordinate plane. In this case, notice it's only the first quadrant because it wouldn't make sense to have negative square footage. So here we have it. Now notice they do not form a line, so it's not a perfect world. So all your lines aren't always going to line up. Actually, most of the time they're not going to line up at all. So since they don't line up, we want to look and see if they are correlated in any way. And so how can we tell that? So again, x is the size, y is the selling price. Size is the independent variable, so it will predict the price because price is the dependent variable. The price, though, doesn't only depend on the size. And the reason we know this is look at the last house, the last two houses. They're the exact same size. They're both 3,198 square feet. And one is 488,000, and the other is 455,000. So two different prices, and they are the same size. So that shows us that size isn't the only factor going into determining the size of the house. There are other factors like maybe where the house is located, how old is the house, how new is the house, what kind of appliances are in the house, does the house need to be updated, does it need to have new flooring, what neighborhood is it in. There are all kind of things that go into the price of the house. But the question here is, does size have any association with the cost of the house? And I think that it does, because if you'll look, as the size of the house goes up, typically the cost goes up as well. So houses that are in the 3,000 square footage range cost more than those in the 2,400, 2,500 square footage range. So if you look at this, even though it doesn't form a great line, they do look like they're grouped around a straight line. So if a line, let's say an imaginary line going here, if you follow my cursor, those points kind of cluster around an imaginary straight line. And as I said before, it looks like they're associated because the larger size houses are associated with higher prices. So two variables have a linear association if the scatter plot shows the data clustering around the straight line, just like we saw earlier on the previous slide. Two variables have a positive association if larger values of one variable are linked with larger values of the other variables. So let me just go back and show you. This is a positive association, a positive correlation, because large values are associated with large values on the y. Large x values are associated with large y values. Two variables have a negative association if larger values of one variable are linked to smaller values of the other variable. So if it looked like the larger the house was, the price was going down. Instead, it would have had a negative association, but it didn't. It had the positive. So here's some examples of positive versus negative linear correlations. Positive, if you look, the larger the x goes, the higher the y goes. So the points don't form a straight line, but they do look like they're clustering around a straight path here. Same thing with a negative, they're clustering around a straight path that goes in the downward direction. The bigger the x is, look what happens to the y's. The y's are getting smaller. They're getting lower. Now, if you look at this bottom one, it's kind of a blob. It doesn't really have a clear line that it is clustering around. You kind of can't tell what it's doing. It's kind of like a fish to me. Anyway, it is a weak linear correlation, and sometimes that happens. Sometimes that happens. And so it's where you can't really see the path, the line that it's trying to cluster around. Now, we can use our calculator to make a scatter plot, which is a really nice feature. So we start the same way we normally start. We enter the data in lists. And to get to list, you will recall you hit Stat and choose Enter for Edit. And then you should see your 6 lists, L1 through L6. Now, once you enter the data, to actually graph the scatter plot, you're going to hit second y equals. The second takes you to the secondary function of y equals. So if you look above the y equals button, you will see the word Stat Plot. So second y equals takes us to the stat plot function, and you will see plot 1, plot 2, plot 3. Choose one of those plots. I usually just choose the first one. It's up to you. And hit enter, and when you do that, you're going to turn the plot on. Make sure you choose on, and make sure you choose the scatter plot icon. I'll show this to you on the calculator in a moment. And then it'll ask you for lists. You're going to put in where the list where your x and your y lists are. So going back up to number 1, when we enter our data in lists, your independent or your x variable goes into L1 and your dependent goes into L2. You're welcome to put them in any of the lists. You just need to keep track of where each list is. So you need to tell it where list 1 is, where list 2, or where the x list is and where the y list is. And then to actually graph the scatter plot, you'll hit zoom 9. Okay? So let me go back a few slides to the home prices, and let's show you how to do the scatter plot on the calculator. So if you go to stat and you hit enter, you'll see your lists. And in L1, I have entered the square footage in the order it was given, and in L2 I have entered the selling price in the order it was given. Okay, so that's what's in L1 and L2. Once I have that, to graph the scatter plot, we're going to hit second y equals. So you see above y equals it says stat plot, so second and then y equals, and you'll see plot 1, plot 2, plot 3, plots off. So I usually just choose the first one, and then you're going to choose on. The other thing is, if you don't want any other data being graphed, make sure the other 2 plots are turned off. When we go to type, this first little icon here with the dots, that is the scatter plot icon, so choose that, hit enter. Then we'll go down to X list and Y list. So where were my X's? They were in L1. My Y's are in L2. The mark, that's up to you. You have the option of an open square, a plus sign, or a dot. I like the open squares. And then once you choose that, then graph it by hitting zoom 9. And there we have a scatter plot. This is the same scatter plot. Here, I'll just show you. It's the same one that is right here. Get them side by side so you can see. It's the same scatter plot, just on your calculator. Okay. All right. Now, we have something called the correlation coefficient. It is represented by the letter R, a lowercase r, and it's a measure of how strong of a linear relationship is between the two variables. Now, it has this beautiful, beautiful, long-looking formula, which is 1 over n minus 1. N is the number of points you have, times the sum of each x minus the mean over the sample standard deviation times the y minus the mean of y over the sample standard deviation of y. Oh, it would take us a while to do this, so thankfully our calculator will do this for us. Now, here are the properties of the correlation coefficient. It can be anywhere from negative 1 to 1. It can take on any value between negative 1 and positive 1, including 0. Regardless of which variable we call x and which we call y, r will be the same. So we can flip-flop the x's and the y's, and we'll calculate the same r. The correlation coefficient only measures the strength of a linear association. So there are other kinds of correlations, nonlinear correlations. We will not be going into those in this class, but just know r only refers to the linear type of association. If r is positive, then that means our correlation or our association is positive. Same thing if it's negative, the association would be negative. Okay, so there's some properties there. There's a few more. The closer r is to negative 1, the stronger the negative linear association is, and the closer it is to positive 1, the stronger the positive linear association is. If r equals 0, then there's no linear association whatsoever. The closer it is to 0, whether on the positive or the negative side, the weaker the correlation is. The value of r is not connected to the value of the slope aside from the sign. So if they ask you the slope of the regression equation, do not give r. It's not the same thing. The correlation coefficient is not resistant. That means it's sensitive to extreme values or outliers. Like we said, it's not resistant, and that means the correlation coefficient may be misleading if they're outliers. That's what that means. Correlation coefficient is not causation. What this means is even if you see there's an association between two variables such as the size of the house and the cost of the house, even if you see there is association, which we saw there was definitely a positive association, that does not mean that one causes the other. It doesn't mean that the price of the house, or I'm sorry, the size of the house causes the cost. Now, it's associated, but it's not causation. All right, so we're going to pause the video here and pick back up with a recall of the house price problem.